Hey, hey guys, Mr. Is here to help you out with the next part of chapter 3 here, looking at complex numbers here. So now we're going to be multiplying complex numbers. So the one thing when we're multiplying radicals is that first thing we're going to do is just multiply the radicals. So we multiply inside numbers, outside numbers, outside numbers, and then we break them down. So if we got radical 2 times radical 18, we're going to get radical 36. But you might look at that and go, easy, I know what the square root of 36 is, but I'm going to do this the long way. We're going to break that down. And luckily, I can just say, okay, well, that's 2 times 18. And 18 is 2 times 9. And 9 is 3 times 3. That's it. We have a pair of 2's and we have a pair of 3's. So 2 and 3 go outside is 6. And then there's nothing left inside, so we don't need to have a square root. So it's just 6. Yeah, because the square root of 36 is 6. Now, if we have something a little bit more complicated, like 3 times radical 15 and 7 times radical 21, we're going to multiply the 3 and the 7 together. So we get 21 radical. And then we got 15 times 21, which I don't know offhand, but that is 315. All right, so then we're going to break that 315 down. So 315 I know is 15 times 21. I just multiplied them together to get that. 15 is 5 and 3. 21 is 3 and 7. That's about as far as we can go. So we can go ahead and multiply or take out a 3 and multiply by the 21 to get a 63. And then inside we have a 5 and a 7 working together, 35. Kind of a weird expression, but that's what it would be. 63 radical 35. Right. Next, okay, if we have number radicals here, what we are going to do this. Now, we have to be careful here because you might want multiply the -4 times the -9 and want to say that it's going to be a positive 36. All right. But the one thing we have to be care of is each time we go to this, if we have a negative, we should make this a I radical 4 times an I radical 9. All right. So when we multiply these together, we get I squared. We'll talk about that in a second here, times radical 36, which if we know 36, the square root of that is 6. But if we were going to break that out, 2 and 3, 2 and 3, 2's are going to break out. Oh, circled the wrong things. 3's are going to break out. So really we get 6I squared. Now, what's going on with this I squared? If we remember, here's a big clue, and you're going to want to write this down. I is equal to the square root of -1. If I square the square root of -1, the square and the square root cancel out. So I squared is equal to -1. So if I have 6 times I squared, really we have 6 times -1. And the answer becomes -6. This is the whole point where I kind of told you before that imaginary numbers, even though they're imaginary, there could be some math later on that we do with them that make them become real. So the answer here is straight up -6. Now, on the next problem, if we got, let me zoom down, I'll scroll down a little bit, clear out my drawings. We want to go through and let's make the I here. So we get I radical 12 times a radical 3. Okay, we didn't have multiple i's. We only have the I here. So if we multiply them, we get I radical 36. Man, why do I keep getting 36 here? Well, this one, we do know that the square root of 36 is 6. And so this answer would just be 6I. So notice the slight difference between this one and the previous one. Why this one is 6I, while the other one was just -6. Okay. So some next things that we're going to go over multiplying. These should be pretty straightforward, but we're going to do it because these things can happen later on. And I just want to make sure we cover that. So if I'm going to take a number like 3 and multiply it by some complex number that has some real part and imaginary part, all I'm going to do is distribute the 3, and we'd get 3 times 2 is 6, and 3 times 5I, which is 15I. So we still have it a real and imaginary part. It's just going through. And same thing if we distribute the negative, we get a -8, and now we get a plus 14I. Pretty simple, nothing to do there. Don't think any of you guys that are in Algebra 2 have a problem with that. Now, where it gets a little interesting is what if we take a complex number and multiply it by an imaginary part? Didn't mean to put the answer there, but actually, you know what I'm going to do? I'm going to delete that. So when I print this off, you guys don't see that. There we go. That never existed. All right, so I'm going to distribute this here, and I get a 3i plus 7i squared. Now, we just talked about that 7i squared is going to become a -1. So we get a 3i, and instead of putting a plus 7i squared, I'm going to put a -7. So now we got rid of that imaginary square and made it real. And now what we want to do is to write this in the proper complex form. Remember, you put the negative, or not the negative, you put the real part first, and then you put the imaginary part. So the proper way to write this would be -7 plus 3i. You see on the next one here, we're going to distribute the 6i. So we get a -24i minus 12i squared. So the -24i hangs out here. The -12i squared, remember, I squared is -1. So I'm going to turn this into a positive 12. Now it's a real. So we're going to go ahead and take our 12 and put that first. That's the real number. And then put a -24i. Next, what if we have some more complex numbers? What if we have some complex radicals that are multiplying them together? Well, what we're going to do here is we are going to FOIL, okay? So complex numbers, we got to do the first part. So 1 times 1 is 1. 1 times negative radical 2 is negative radical 2. Next, we'll distribute here. Negative radical 2 times 1 is, or no, that's a positive radical 2 times 1 is a positive radical 2. And then a positive radical 2 times a negative radical 2 is a negative radical 4. Now, if we have any like terms, we can combine them. Or we should break them down too. Let's actually break this down. So I'm going to break this down. That's 2 times 2. So really, square root of 4 is just regular 2. So this becomes a 1. And then the negative radical 2 and the positive radical 2 cancel each other out. We get -2. It's going to be a -1. So these two complex numbers, if we multiply them together, become something pretty simple. Now that doesn't happen all the time, but what we can see here on the next, we were to FOIL here. 4 times 1 is 4, minus 4 times 3 radical 10. We're only going to do the 4 times the radical 3, or the 3, and get 12 radical 10. Now on the bottom here, we're going to distribute the -2 radical 5. -2 radical 5 times 1 is -2 radical 5. And then lastly here, we get -2 radical 5 times -3 radical 10. So the -2 times the -3 is a +6. And then the radical 10 times the radical 5 is a radical 50. All right, so let's see. Can we break any of these down? No, we can't break down the 4. 12 radical 10. 10 is just 5 and 2, so that doesn't break down. 2 is, no, that's 5 is 5. Okay, what about 50? 50 is 5 times 10, and that is 5 times 2. Distribute, we can actually multiply this 5 out in front, and we get a 30 radical 2. Man, we broke out all the radicals. None of them are the same. We can't combine them. So this long answer is just the answer. And that's what happens sometimes. All right, now let's go ahead and look at multiplying complex imaginary numbers. All right, so we're going to FOIL here first. So we got 2 times 4, which is 8. Minus 2 times I is 2i. And then with the 3i, 3i times 4 is 12i. And then 3 times -i is -3i squared. All right, so we can combine those and rewrite this as 8. -2i plus 12i is a +10i. And then -3i squared becomes a +3. And now, actually, after that, we can combine the 8 and the 3 together. So putting the real numbers first, we would have 11 plus 10i. Kind of like doing these ones. It's like a little extra surprise twist ending. All right, do this next one here. We're going to do 5 times negative 3 is negative 15. And 5 times negative 6i is negative 30i. Now at the bottom here, distributing the negative 2i. Negative 2i times negative 3 is a positive 6i. And then negative 2i times the negative 6i is a positive 12i squared. All right, we can combine those together and rewrite this. So we get a negative 15, and then we'd have a minus 24i. The negative 30 and 6 makes a negative 24. And then the 12i squared becomes a negative 12. And then we can actually combine those together. So the negative 15 and the negative 12 makes a negative 27 minus 24i. All right, guys, that wraps up multiplying complex numbers. We got one more thing to do, which would be to divide complex numbers. Thank you guys for watching. You guys have a great rest of your day.